If you take a look at the outcomes, this is a teeny tiny little unit, so it's basically going to take us through this week, so you're looking at a test next week sometime. Probably tomorrow or Wednesday I'll give you the March calendar so you'll know exactly when, but this unit does not take us long at all. Let's first just look at what the word means. Again, you started this in grade 8, so you've seen this before, but you maybe never took a look at the actual word. So trigonometry can be split into 3 sections: tri, gono, and metry. You probably know what the word tri means, like a tricycle or a trinomial from algebra. What does tri mean? 3. Let's go to metry. It's a Latin word. It's a suffix, and it means measure. Commonly see it in geometry, which is another branch of math, which is the measure of shapes in space. Gono, really weird word, Latin. Anyone want to guess? What does gono mean? Close. What else would we have 3 of? Kind of. Angles. So if we put those together, 3-angle measure, what do we call something with 3 angles? So it's the measurement of triangles. Its application to pre-cal is there is so many things in the world that form right-angled triangles, so a lot of construction, engineering, architecture will use this kind of stuff. In pre-cal, you'll find out in grade 12, if you follow the pre-cal stream, this is the basis of pretty much all math. All comes down to trigonometry. So let's just review a little bit from grade 8. So right-angled triangles when it has a little square in the corner, and that indicates 90 degrees. This is probably a brand new symbol you haven't seen before. We'll talk about him in a second. But you should have talked about at least the name of this side right here. Have you seen an H before? Hypotenuse. High five to whoever said it. Hypotenuse is always the longest side, and it's always opposite the right angle. And it's such a weird word. It also comes from Latin, which is the foundation of Greek, and in Greek it means longest side. So it's actually literally called the longest side. The side that's opposite the given angle, well, let's talk about this little guy right here. He's a variable. He's like X or P or Q or A. He just happens to be a Greek letter instead of an English letter. And why would we start throwing Greek stuff into this? What do the Greeks have to do with this? They invented it. Who is the famous Greek mathematician who invented this stuff? You learned about him in grade 8. He has his own theorem. Pythagoras, right? It's Pythagoras that started all this. And if you look at my history of math timeline at the back there, and you go all the way to the start where it starts with before the year 0, and the bottom picture is the 3 Egyptians/Greeks playing in the sand with right-angled triangles. I'm just going to pause for a second because you don't need to know any of this next part, but it's just kind of interesting. So in homage to the Greeks, we always use this letter to represent an angle. So it's just like X, it happens to be Greek. Anyone know what it's called? What letter is it called? It's called theta. And I always like to spell it because I had a student years ago that graduated from grade 12 thinking it was feta, like the cheese. Very yummy cheese, but not the same thing. Theta. Anyone know the equivalent to our English letter? Because most of the Greek letters, we have an equivalent. So I want to guess our equivalent. Good guess, because it looks like an O, but it's not. Not an H. It is a T, and it's kind of like RT that's got that curve to it. Can you see the similarity there when I put the curve? So it's a small letter T in our alphabet. Again, it's just a variable. It's like X, it's like P. We just use Greek because it was Pythagoras and the Greeks that invented all this. Why do we need to know that? Well, because the side that's opposite that angle has a special name, just like the hypotenuse. And want to guess the name of the side that's opposite theta, Brock. Yeah, that's how obvious mathematicians are, by the way. We're really, really literate people. So the side opposite the given angle, which we call theta, is called opposite. Mathematicians, really, really obvious people. And what letter do you think we give opposite? Because we don't like writing that out. That's way too many letters. So hypotenuse H, opposite. Oh, that's right. Well, the third side also has a name. So hypotenuse is opposite the right angle. Opposite is opposite the angle. And whatever the leftover side is has a name. So the name comes from an English word which you may have heard. It's called adjacent. Does anyone know what adjacent means? Right beside or next to. So I want you to reach out and wave hi to the person who is adjacent to you. Say hi. Say hi to the person who is adjacent to you. Okay, could be either side, could be kitty corner, same idea. So it's the side that is attached to theta. That's what we call the adjacent side. Letter? A. Yep, that's how obvious we are. O, A, and H. So what we're just going to practice for example 1 is just naming the sides, because everything we do in trigonometry, we need to know what the sides are called. Easiest way is just to start with the hypotenuse, and the hypotenuse is always opposite the right angle. So if you can find the two sides that make a 90-degree angle, so they form like a letter L, come directly opposite, that's going to be your H. The next easiest side is O, so you take wherever theta is, go directly opposite, and that's going to be the opposite side. If it's not H and it's not O, what does it have to be? A, and that's the one that forms the other half of theta. So the naming will always work that way. Opposite the right angle is hypotenuse, opposite the angle is opposite, the other side, or the one that forms theta, is called adjacent. Okay, so there's our right angle in the second one. Come directly opposite, we call that H. Find theta, come directly opposite, we call that. And the one that's left? A. Name the last one all by yourselves. Opposite the right angle, or the longest side, we call H. Directly opposite the angle, we call O. If it's not H and it's not O, it has to be A. Who got those 3 correct? Awesome. That's the key. If you can't name the side, you can't do the rest of the unit. So if you're having issues with that, you need to come and see me ASAP to fix that, because again, the rest of the unit is based on that. So what we're going to talk about for the rest of the unit is called trigonometric functions. Sounds so fancy, trigonometric functions. Trigonometric just means they're part of trigonometry. Function just means it's like a little equation. And you've probably maybe heard these before. So the first one we call sine, not sin. It's called sine, S-I-N. The second one is called cos, not cos, cos. And the third one actually sounds like the way it's spelled, which is tan. And these are actually all 3-letter abbreviations, and we abbreviated them so they'd be able to fit on the calculator buttons. This is actually short for the real function, which is called sine, which is S-I-N-E. And we've just abbreviated it to 3 letters. That's why it's sine, not sin. And cos is abbreviation for the function cosine. So we have sine and cosine. Abbreviate that to sine and cos. And tan is an abbreviation for tangent. Did anyone have Mr. Lockhart last year? So I joked that that's his function, tangent. Come on, that's funny. Again, we call them sine, cos, and tan, but they are abbreviations just so it fits onto your calculator. There's actually 3 more functions you won't meet till grade 10, but there is a cotan, or sorry, grade 12, a cotan that goes with the tan. So there's sine, cosine, tan, cotan, and there's 2 others. So these are actually sometimes called trig ratios, because a ratio is just a fraction. And what the sine of theta equals is always the opposite side divided by the hypotenuse. The opposite with a T side divide by the hypotenuse. That's what sine equals. You take the O, divide by the H. Divide, yep, it's a fraction. Cos is a second trig ratio, which is the adjacent side divided by the hypotenuse, or A divided by H. And the third trig ratio or trig formula is tan, which is opposite, divided by adjacent, or O divided by A. You need to memorize these formulas. Won't be given on a formula sheet. You need to just know them. And here's the acronym we use, and you've probably seen this in math rooms since about grade 8 and probably wondered what the heck, is we write SO, S-O-H, CA, C-A-H, and TOA, T-O-A. SO-CA, TOA. Which there's a bad joke. If you bang your foot, what do? TOA. No, not at all. What does this represent? Well, this is the three trig functions. This is sine equals opposite over hypotenuse. This is cosine equals adjacent over hypotenuse, and tan equals opposite over adjacent. It's on my wall. It will always be on my wall, so you just need to know SOCA TOA to know the three formulas. It's the white sheet, the second from the door, or the third from the back wall. Okay, it'll always be on there. Okay. What does this mean? What do we do with it? Well, we use these formulas to find stuff. We're going to look at finding a side, then tomorrow we're going to look at finding an angle. So here's a typical trigonometry question. You'll get a diagram like this. They'll give you some information, and there's an x, and the directions are find x. Well, why do we need all this if we had Pythagorean theorem? It was good. A squared plus b squared equals c squared. That was easy. We mastered that in grade 8. Well, why do we need these new formulas? Right, because we're given an angle, and do we have two of the sides? No. So Pythagorean theorem was great. It's just now we're stepping it up, and we're actually giving you angle values, because that's what happens in real life. Rarely are you given two of the sides. Typically, you have to measure an angle and find a side. Do you want to see an example first and then write the method, or do you want the method and then see an example? Method first, okay? Step number 1. Label sides. And you only want to label the sides if they have a value or a variable. If the side has nothing on it, don't label it because we don't need it. So you're going to label the sides that have a value or a variable. Step number 2, choose the formula. And this is where we use that SOCA TOA, which I'll explain when we do the example. So step number 2, choose the formula, SOCA TOA. Step number 3, substitute into the formula. Substitute into the formula. Step 4, isolate the variable. And the last step, use your calculator. If you have your calc here, grab it. nice thing about this is those steps will always work. They're never going to change. There's no exceptions. Those are the 5 steps every single question. So there's way less thinking in this unit than last unit. You know, to think what shape, what formula, is it surface? This is just straight up, here's the 5 steps. Step number 1, you want to label sides. You only want to label if there's a variable or a value. If there's nothing there, don't label. So I'm going to first mark the right angle. I have to label 17, and I have to label x. So I'm going to come opposite the right angle. What do we know about 17? H. X is opposite the angle. What do we know about the side that's opposite the angle? O. I'm not going to name the bottom side. I'm putting nothing there. Why? Well, there's no variable, there's no value. And what happens if you name all 3 sides, you can't pick a formula. The reason we only label 2 is because now we look at our SOHCAHTOA. TOA. Do we have O and H, A and H, or O and A? Because we can only have 2 of those possibilities. Which of the 2 do we have? O and H, so the formula has to be sine. That's how we use SOHCAHTOA. The last 2 letters is whatever you have on the triangle. The first letter is whatever formula we're about to use. So step number 2, our formula is sine theta equals O over H. Sine theta equals O over H. Step number 3, we're going to substitute in. I'm leaving sine because that's a function. It's a button on our calculator. Do I have theta? Do I have an angle value given in the question? 60, so I'm going to put 60 in there. Do I have an O? Someone turn the phone off. What is O? It's x. And what is H? 17. That's step number 3. You're always going to end up with a variable left and everything else should be numbers. Step number 4, we want to isolate the variable, just like when we solve any equation. So if we look at this right-hand side, what's the opposite of dividing something by 17? So I'm going to multiply each side by 17. And you'll notice on the left, I just threw it in front of the sine 60. So I have 17 sine 60 equals x. Grabbing my red pen, I'm going to add something after step 5, is you need to check your mode button. Just like in Unit 1, we looked at 2 different systems to measure lengths. We looked at the imperial system and the metric system. There are also 2 different systems to measure temperature in the world. We use Celsius. What's the other one? Fahrenheit. There's also different ways to measure angles. We use degrees, but there's 2 other systems in the world, and so you have to tell your calculator which system you want it to calculate in. So before you do a trig question, you always want to check your mode button, which is right beside your second function. And 3 lines down, the degree button should be black. So mine is not black right now, which means I have to change it, and so I'm just going to move so I'm on top of the word degrees, and I'm going to hit enter. And do you see how it flipped from radian to degree? Okay. In grade 12, you'll learn radians, and that's why sometimes my calc is in the other one, because I might have been doing something with them, but you want to make sure you're checking every single question. If you play games on your calculator, sometimes it automatically flips it back for you because it's programmed in radians, so you want to always make sure. You'll also know if you're doing a test or an exam and you get really weird answers, it's probably a mode issue. So it's always the first thing you check before typing your calculator is your mode. It depends what kind of programs you use on your calculator. So sometimes it flips it out and you're not aware that it does. So I just like to always check the mode. Just check it, check it. Again, you'll know because you'll start getting really weird answers and you'll be like, oh, my calculator's broken. I'll be like, it's not the calculator. So check your mode. You want to make sure degrees is black. When it's black, you just quit out of that. So second function mode is the quit button. And now it's all good to go. The beauty of the graphing calculator is you're going to type in exactly what you see. I'm going to hit 17. Then I'm going to hit sine. Now it opens a bracket before the 60, and that's fine. It just means you need to close it after the 60. So it puts in the first one. We're going to type 60, and then we're going to close it off. Okay, so you get exactly what we see, 17 sine 60. Hit enter. The length of the side that we want is, what's the rounding if the question doesn't say? Okay, so 14.7. And what's nice is you have a built-in check. What do you know about the hypotenuse? What's special about the hypotenuse? It's always the longest side, so could this answer be bigger than 17? No, so it's nice you've always got a kind of built-in check. It's got to be somewhere around 17 because it's a fairly long side, but it can't be 30, for example, or 100. Or sometimes if you're in the wrong mode, you'll get 0.0001. Well, would it make sense that a side's going to be 0.0001 centimeters or inches? Right? So it should be around the hypotenuse but can't be bigger. There's your first trait question. I'm just going to label the steps. So step number 1 was actually just labeling on the triangle. Step number 2 was picking the formula. Formula comes from SOHCAHTOA. We had O and H, so we picked sine. Step number 3 was substituting into the formula. Step number 4 was getting that x by itself. And the last step was using your calculator. Again, you're going to see after the examples what's nice about this is the exact same steps every single time. There's no exceptions. They're not going to change. It's always going to be these 5 steps. Show me your thumb. I'm getting this. I'm kind of getting this. Good. Okay, let's do another one. Step number 1, label the sides. We start by putting in the right angle, because that's going to help us determine if we have the hypotenuse and if we have to label it. 30 is directly opposite the hypotenuse. Oh, the right angle, so it's called hypotenuse. Now, opposite the 62 would be O, but do I need to label that? And the problem is if you label all 3 sides, you can't pick a formula because you don't just have 2. So I'm not going to touch the opposite side. I'm not going to label it. Well, what does x have to be? If it's not h and it's not o, it has to be a. You also know it's a because it makes up one of the sides of our 62 degrees. Step number 2 is pick a formula. So SOHCAHTOA. You're looking for what are the 2 things you have labeled. A and h. Which formula? Cos. So cos theta is a over h. Step number 3, we're going to substitute in. What's the given angle in the question? What do we have where we labeled A? What do we have where we labeled H? There's step number 3. Step number 4 is just to isolate the variable in the equation. What's the opposite of dividing something by 30? Multiplying by 30. And I'm just going to stick it in front just like we did in the last example. So I get 30 cos 62 equals x. The very last step. Check your mode, and I know this feels redundant, but you need to get in the habit of checking, because if you do that now, by the time we get to grade 12 and we're flipping back and forth for systems, it's going to be ingrained. So check your mode, then quit out of it. Type exactly what you see, so 30 cos 62, close the bracket. To 1 decimal place. Offer 14.1, confirmed. Just double check, does that make sense? Is that smaller than the hypotenuse? Okay, so it has to work because it has to be less than 30 and it's not a super crazy number. Do you see the similarity between these 2 examples? Yep, by the time we do 2 more, you're going to be like, yep, same 5 steps every single time. Okay, step number 1, label the sides. I like to draw the right angle first because that helps us get the hypotenuse. Opposite the right angle is hypotenuse, so it happens to be x. Across from the angle is O. Don't write anything on the bottom. Why not? So why am I not going to label the bottom side? If you do all 3, you can't pick a formula, plus there's nothing there. There's no variable, there's no value, we just leave it. Step number 2, SOHCAHTOA. SOHCAHTOA, O and H, sine. Okay, let's fill it in. Sine of, what's the angle in the question? 37. O, H. There's step number 3. We already have done our steps. What do you notice that's different between this example than example 1 and 2? X is on the bottom, okay? We're still going to have to isolate it, so we're going to go through the same steps. What's the opposite of dividing something by X? Multiply by X. And I just stuck it in front, just like we did on the other questions. Now I want you to box sine 37. Those are stuck together. We can't split up sine and 37. So what's the opposite of multiplying x by sine 37? Dividing. So I'm going to divide by them stuck together. So we end up with x equals 50 over sine 37. Okay, so I multiplied by x to get rid of it on the bottom on the right, and then I divided by sine 37 to get the x by itself. The last step, the best step is grab your calc, check your mode, degrees, good to go. How am I going to type this in? This is crazy talk. Look at all that. Type exactly what you see. What's going to go first? Then? And if you've got the new operating system, it'll flip into a fraction. I do not, so it's just going to stay as a division. And then? Okay, so yours might look like a little fraction. Mine looks like the same with division. To 1 decimal place. Offer of 83.1. Whoa, whoa, but that's bigger than 50. So is that okay? It's bigger than 50? How are you feeling so far? Do you notice that the steps are the same every single question? That's the beauty of these. It's not going to change. With me, with a partner, by yourself, how are you feeling on example 5? You want to try it on your own? Yep. Okay, try on your own, then we'll talk in a couple minutes. Work with a partner, work by yourself? Yeah. I'm just going to slowly start working after you so you can check as you go along. Mm-hmm. That is so distracting to a visual person. I can't stop staring. How many people picked tan? Good job. I'm going to show you a quick way to isolate x. So if you want to do it like the last example in 2 steps, great. Here it is in 1 step. What you can do is take the tan 42 and the x and just switch them. So the x comes up, and the tan 42 goes down. Okay, so it's exactly what we did in the last example. It's just 1 step instead of 2. So if you like that, great. If you like the 2 steps, great. Whatever your brain likes better. Somebody have an offer? Offer of 125.2. Okay, and let's just check, does that answer make sense with our other value? So if we have 112, yeah, it makes sense we could have 125.
Sorry for the interruption. If we could please have the following 2 individuals with license plate FKZ500, and the other license plate is HAD683. If you could please come to the office for a minute. Thank you.
When you own the car, you do, because you have to give it all the time. BAT950, it's Batmobile. Questions on this? One more to do. Word problem. Uh-oh. It's okay. No, they don't scare us. They do not scare us. We have a system. Word problems are our friends. What's the first step? What do we do first? We just read to read. Don't overthink it. Don't stress about it. Just read it like it's in a book. Kate, now let's read to understand. The first sentence. It's a ladder. School, wall, building, we don't care. It's leaning against something. Sentence number 2. And what is? So I just want to highlight foot, and foot just means bottom of the ladder. Okay, the last sentence, the first half. With the, okay. And what are we looking for? Length. Now you're going to learn what? I don't teach arts. There's the ground. There's the building. Here's my ladder. Where's the 90-degree angle? Building and the ground. We hope they make 90-degree angles. Let's hope. Okay, we got 2 values. We got 2 and 30, and I know I need to put an X somewhere. Anyone want to wager in where the 2 might go? Brock? 2's here. Okay, how do we know the bottom is 2? Because it says the foot from the base, so that has to be the length of the bottom of the ladder to the building. Where is the 30 going to go? Bottom right. How do you know that? Because it says the foot of the ladder and the ground. So that's the only angle that's formed by the foot and the ground. Where is our X going to go? Do we want to know how high the ladder is, or do you want to know how long it is? Long, so it has to be the length of the ladder. If the question asks how far up the building or what's the height of the ladder, then we're good to go. Once we have a triangle, we're back to the same 5 steps. Step number 1 is label the sides. What would you like to call X? What would you like to call the 2? Why A? Because it's not opposite, and we know that it's adjacent to the angle. Pick a formula. So katoa. Cosine of theta equals cos of equals how do we isolate the variable? Well, again, you can do the 2-step like example 3 or 4, sorry, or you can do the 1-step like example 5. I like the 1-step, which is where you're just switching those 2. So X comes up, cos of 30 goes down. If your brain needs 2 steps, use 2 steps. There's nothing wrong with that. This is the best part where the calculator gets to do all the work. Offer of 2.3. Confirmed, and because it's a word problem, meters. There we go. Who's liking trig so far?